Good morning. My name is Dwayne Davis. I'm Tech Support Manager for Associated Research. I'd like to welcome everybody today to our webinar entitled, Is Repeated Hipot Testing Destructive if Performed According to Established Standards? This webinar we've kind of put together in response to a lot of questions that we've gotten over the years about doing Hipot testing multiple times on products, and are we destroying the insulation, this kind of stuff. We've done a couple different versions of this. This is kind of a little updated. Hopefully I can add a little bit more information, and we'll talk a little bit about the tests, why they're done, how they're done, and some of the test results and stuff that's happened over the years and things here. Joining me today is Jim Kennedy. He's our host. If you have any questions or problems regarding the meeting, as far as any audio or visual problems and stuff, please address those to Jim through our chat line, and he will try his best to get those resolved to you as quickly as possible. Assisting me today is Peter Stevens, and Peter will be answering questions and stuff that you may have during the presentation through our Q&A facility and stuff. So you can address those to Peter using the Q&A facility, and he will either respond to you directly with those, or he will interrupt me and we'll try to answer those questions as we go through the material. So again, welcome everybody, and thank you for joining us for our first webinar of the year. And let me run through the outline real quick. We're going to talk a little bit about trying to define what a Hipot test is and why it's required. We're going to review essentially 4 categories of Hipot test. Essentially what they are and why they're performed, or what is their application. Who actually needs to perform a Hipot test? What are some of the problems that actually can be detected by doing a Hipot test on your product? What actually causes insulation failure? Is AC or DC testing more stressful? And is repeated testing destructive to the insulation within your product? And we're going to review some test results of, some tests that we've done here on a couple different types of products, where we've set it up and done some repeated testing on it and monitored leakage currents, during the test time, this kind of stuff. We did not take these products to the point of destruction. So I don't know if I can actually answer the question, how many tests are too many, but we can give you a pretty good representation and stuff here of what has actually went on during the test itself. So, with that being said, what is a Hipot test? Hipot is essentially an acronym for dielectric voltage withstand test, a high potential test. And this test is essentially designed to stress the insulation of an electrical device beyond what it normally will encounter during its in-service use. The test potential is not high enough to result in undue damage, but it is there to give you a pretty good evaluation of the insulation to make sure that it will guard against any electrical shock hazards that could exist during normal operation of the product, this kind of stuff. It's assumed that if the insulation can in fact pass this higher stress potential, for a given period of time, it can function adequately throughout the normal life cycle of the product itself. And this is where the term, voltage withstand test actually comes from. one thing to keep in mind, why the test is actually done. We actually are, putting a stress across the insulation, and how do we determine what potential we should be applying during the test? Well, many of the test samples and stuff that have been done on the product, we go through and we take them to the point of failure where we've determined at what level the insulation will in fact break down, and then we essentially rate that material to operate at a working voltage or stress that is much lower than what that breakdown potential is. And this is how we kind of go through and we grade insulating materials, this kind of stuff. The insulation itself is based upon the operating voltage, the pollution degree, what is it meant for indoor use, outdoor use, what kind of environment, this kind of thing. All these come into play whenever, we're talking about the electrical insulation of a product itself. But anyway, the 4 different types of categories that I want to try to talk about briefly today of different Hipot tests are, first off, type testing. What is that? How is it different from maybe a routine production line test or maintenance test? And what is actually a breakdown test? These are essentially the 4 different types of categories of Hipot test that we're going to talk a little bit about. What is the intention of going through and doing these tests? Some of these, in fact, are destructive by design. Others are not meant to be destructive. And we're trying to kind of maybe rule out some myths about Hipot testing being a very destructive test. I think one of the points that I'm going to try to prove today here in some of the stuff that we're presenting is if the test is done in accordance to national standards, it's really not meant to be a destructive test. It is designed to try to catch problems, and that's the reason why we're going through and we're doing the test itself, is to try to make sure that the product that we are selling in fact is not going to cause any shock or fire hazards to the individuals that are in fact using the product. If we keep that in mind about the Hipot test, I think it kind of sheds a little bit more light on why this test is actually being performed. But anyway, let's talk a little bit about a type test. When a product is designed, it should be designed having some established limits, operating voltages for the insulation within the product, the conditions itself that it's going to be used under, what kind of pollution degree, this kind of stuff. The type test is done to evaluate the design of a product to make sure that it in fact is safe. In some cases, products are tested to the point of failure to determine the adequacy of the design itself. The dielectric voltage withstand test, specified as the type test, is normally done between main circuits, which is line and neutral conductors typically tied together, and high voltage is connected to these circuits, and the return is connected to any exposed dead metal or to earth. So we're testing essentially the primary input of the product to any exposed dead metal. The test potential for a type test in many cases is anywhere from 1,000 to 1,500 volts for a Class 1 product, 2,500 to 4,200 volts RMS for a Class 2 product. When we're performing these tests, all switches in the supply circuitry should be in the on position, and in many cases, the tester itself must have a output current capacity that will provide up to 100 milliamps of current under full load conditions, and also maybe a 200 milliamp short circuit capacity, just to make sure that the voltage potential is going to be maintained at the proper level throughout the duration of the test itself. So these are some of the requirements of a type test spelled out by some of the various testing standards. And this is testing essentially mains to chassis ground or mains to earth or any exposed dead metal. The secondary, also there may be some requirements for testing mains to secondary circuits to make sure that there is proper isolation between these circuits also. And those would be done at, typically a higher test potential depending upon, the isolation required for the product itself between these types of circuits. Okay. The routine production line test, these tests are normally done on 100% of the products that are being manufactured. This test is performed for a couple different reasons. You want to make sure that the product itself is safe. You want to reduce the possibility of having to do a recall on your product itself if a hazard does in fact exist. If it has been tested, you have some assurance that the insulation within that product itself will stand up to normal day-to-day operations. And some abuse to a certain degree, of the product itself, again, to make sure that it's safe. The routine tests are done to detect potential shot hazards that could be due to inadequate creepage or clearance distances, manufacturing defects, possibly pinched wires where the insulation in fact is damaged, improper spacing of components. Potentially some wiring errors can be caught with a Hipot test. If somebody reverses maybe a neutral and a ground, or a hot and ground conductors, this type of stuff, these type of wiring errors can be detected. If it has to do with, essentially primary circuits in reference to earth, you wouldn't find a line to neutral short in doing a Hipot test because these two circuits are in fact tied together. Typically if you're testing a product or an appliance, this type of thing. Depending upon the product itself, if you're testing breaker panels or something like that, then the panel itself, we're talking like a load box, you have to test circuits that are of different potentials, to each other, just to make sure that there is no short between, line to neutral or line to line type configurations also. Maximum allowable leakage currents during a Hipot test. In a type test, it could be up to 100 milliamps, which is very common in many cases. In a routine production line test, we normally see leakage currents that are much lower, usually in the area of 5 to 30 milliamps. Again, depending upon the standard. Your product may draw much less than that. So Some safety standards will allow you to set the trip current on the Hipot tester to a value that is slightly higher than the leakage current that is normally seen during the Hipot test, but not to exceed a certain value and stuff in other cases. Example, 60335 standard for household appliances. In doing a routine test, that standard specifies trip ranges normally from 5 to 30 milliamps, depending upon the product and stuff that you're testing itself. And that value is selected typically by the manufacturer. So it's up to you to determine where do you set the trip setting, on your Hipot tester. Other standards may specify using a 120 k ohm resistor to set the trip setting, where you adjust the test potential of your Hipot to the voltage that is specified by the test, and when you connect a 120 k ohm resistor across the output, the tester itself must fail within a half a second. That's spelled out in a lot of safety standards. And some other standards do not specify a trip setting at all. It's up to you to determine that. So there is quite a large variation in where do you set your trip point at. That's kind of up to you, to determine based upon the product that you're manufacturing. Whenever we're doing a Hipot test, the test potential should be high enough to break down any weak insulation. That's the intent of the test, by overstressing it, but not high enough to break down good insulation. It is important to follow the safety standard, test in accordance to the safety standard. I've had some customers that say, well, we're manufacturing products that are rated for 115 volt operation, and some that are also rated for 230 volt on the input. Standard rule of thumb may be specifying 1,000 volts plus twice the input. So in some cases you may be looking at 1,200 to 1,240 volts for a 115 or 120 volt rated product, where for a 230 volt rated product you may be testing somewhere in the area of 1,500 volts. So I may just decide to go ahead and test at 1,500 volts just to make sure that every one of my products and stuff that I'm manufacturing are tested to the same test potential. I don't have to mess around with changing my my Hipot. Word of warning, be careful in doing this. Some of the safety standards specify that the test potential cannot vary more than, I think, 5% of the rated test potential. So, if you try to do that, you may not be testing in accordance to the standard. You may get written up by the safety agency for not testing in accordance to the safety standard itself, because you tested higher than that than the rated test voltage for products that are rated for 115 volts. So anyway, maintenance test. A maintenance test is a test that can be done on products after being manufactured, after it's been put in service. Some countries, we've seen some European requirements where a maintenance test may be performed or required to be performed on tools that are rented to the general public, where before the product can be rented back out to somebody else, they've got to go through and perform a routine Hipot test on it as a standard test to make sure that it will pass both maybe a ground bond test and a AC Hipot test. to verify the ground conductor is in fact intact and good, and to also verify that the insulation within the product has not been damaged before it can be rented out to somebody else. Maintenance test is also done on some medical equipment, hospitals, this kind of thing. You see maintenance tests being done on large rotating machinery to try to predict potential failures of the equipment. This is where a lot of controversy has come in on doing AC Hipot testing on large, say, AC motors. And I think a lot of this is misinterpretation of what potential should actually be applied. Typically, when you're doing a maintenance test, the test potentials are normally reduced to 60% of the factory test voltage or less. They're not tested at the same test potential. Why? Well, over time, insulation will age. It will could possibly be damaged. It could crack. The insulation itself could dry out, become brittle. Moisture could be absorbed into it. So the insulation itself could be degraded over time. Now, you kind of have to ask yourself the question, well, isn't this something that I am wanting to detect in going through and doing this test? That's the whole purpose of the Hipot test. You know, this is true, but you also don't want to shorten the life of your product by, you know, possibly testing, you know, too much or testing at too high of a potential where you could possibly damage the insulation. Maybe an insulation resistance test might be a better choice over an AC Hipot test, or even a DC Hipot test might be a better choice in some cases, where you could, if you're, say, doing a step voltage test, monitoring the leakage current, you know, during each step, and where you can actually possibly predict a failure before it actually happens, looking for maybe a knee and a curve, you know. If you're doing comparison test, looking at leakage currents of the product itself, comparing them to tests that have been done in the past, where you may see some variations in the test itself. This is a test that is commonly done in doing a maybe an insulation resistance test on the product. Again, doing those tests, do them in accordance to the standards. Don't just make up some numbers. You know, if you're doing them according to the standards, you've got some tests that have been chosen based upon some actual history on different types of insulation, different types of product, this kind of stuff. You know, you're not using one number fits all type thing, because it doesn't, you know, to go through and verify the insulation is good or not. Okay. A breakdown test. The breakdown test is actually performed on different insulating materials to determine the breakdown voltage of that insulating material itself. This is, in fact, a destructive test. You know, a voltage is applied to the insulation. It's ramped up to the point where the insulation actually fails, and it will actually discharge either through or across the insulating material, indicating a failure itself. The voltage at which the insulation or dielectric ruptures or ionizes and the condition take place in either a gas or vapor. This is kind of one of the definitions of actually doing a breakdown test on some different types of insulating material itself. Again, this test is in fact destructive. It is normally done just on a sample basis. If you're doing a breakdown test on your products, I don't want to buy them. It is in fact a destructive test. It is not meant to be done on products that you're marketing to your customers and stuff here. Okay. Who actually needs to perform a dielectric voltage withstand test? Well, if you manufacture an electrical product that operates from power line voltages, you should be performing a dielectric voltage withstand test on that product. This test is done to protect the user of the electrical equipment from an electrical shock hazard. The test itself is usually incorporated at the end of the production line, and it's performed on every product that you produce. So, it's done to verify that the insulation of the product itself is good, that there hasn't been any workmanship problems that have occurred that could have damaged the insulation. There's adequate spacing, between what is meant to be a circuit that is carrying line power and circuits that are not meant to be carrying power. Okay, so the ground circuits or any metal enclosures of the product itself, any exposed dead metal. Okay, problems that you can detect by a Hipot test: excessive leakage current can occur in doing a Hipot test. Let's face it, the leakage current itself, if it gets too high, this can create a shock hazard, especially if somebody defeats a safety feature in your product. If your product is meant to have a grounded metal enclosure operated where you have a ground circuit in the product, a Class 1 product, and somebody defeats that ground circuit, if the leakage current is too high, from the primary circuit to the enclosure of that product, it's going to create a shock hazard to the individual as soon as they come in contact with it. The first time I was ever shocked that I can remember, I was shocked off my parents' refrigerator. I grew up back in the 1950s, and my parents' home was wired where all the outlets were only two-prong conductors. There wasn't a ground circuit in that house. The refrigerator itself, what we had was an old, Philco refrigerator that was not grounded, and it was before the days of frost-free refrigerators and freezers. If you wanted to get an ice cube tray out of the freezer, the easiest way of doing it was to reach over to the kitchen sink, grab a table knife out of the drawer, and jab it underneath the ice cube tray to pop it loose, because chances are it was frozen in place within the freezer. Just so happened the kitchen sink, back in the 1950s, it was very common to have metal sinks, metal cabinets, all tied to a nice ground system, the water pipes. So if you came in contact with the refrigerator enclosure, in this case the handle of the refrigerator, and you reached over and grabbed a hold of the drawer to open it up to get a table knife out of it, you got a pretty good tingle off of it. It got your attention. I heard all sorts of colorful language from my mom every time that she did it. She'd reach over and grab a hold of the refrigerator. It was a good shock. It wasn't lethal, but it was enough to get your attention. And this was due to leakage currents. Okay. My brother enlisted in the Navy. He took up electronics, and one of the first things he did when he came home on leave was apparently he did it and got shocked, and he put a ground wire on the refrigerator, and you know, that took all the fun out of it. You know, you couldn't get zapped off of it any longer. But you know, it did create a shock hazard. It would create a startle reaction. It was enough to get your attention. Okay. If the leakage levels are in fact too high, then you know, this could create a you know, a Hipot failure itself, depending upon where you're setting your trip levels. Leakage damaged insulation resulting in electrical breakdown are in fact detected with a Hipot. Insulation voids, trapped foreign particles, this kind of stuff, this may cause an insulation breakdown. Manufacturing defects, some types of wiring errors, improper spacing with respect to ground. Air is an insulator. If spacing is too close, you're going to get a you know, a arc over. You know, it could result in the you know, the conductors or carbon tracking across, you know, surface of an insulating material. So, you know, if you're jumping a gap, if you don't have adequate spacing, that's going to create a failure itself. Heat, scrapes, pinholes, crimps, age, as insulation gets older, it might become brittle, crack. Vibration can actually cause damage to insulation itself. Moisture, you know, this can lower the insulation resistance. Improper spacing with respect to ground. You know, all these things are different types of failures that, in fact, can be detected with a Hipot test. And this is part of the reason for going through and doing the test on the product, is trying to find some of these problems. Okay. Which test is more stressful? Is AC or DC Hipot testing? AC testing typically is thought to be more stressful than DC. It does test the insulation typically in both polarities, both on the positive cycle, on the negative cycle. It's thought to be more of a go, no-go test. And part of the reason for that is that the leakage current that you see during an AC Hipot test is the total leakage current that flows through the product, that is due both to the capacitive reactance of that product itself and the insulation resistance. Keep in mind, whatever you're testing the insulation between two conductors. That's a capacitor. You know, so if I tie my line and neutral circuits together and I'm testing the insulation between my primary circuits and ground, it's a capacitor. The more wiring involved, the more circuitry involved, the higher the capacitance, the higher the leakage current. So, you know, this in fact could be the leakage current that is due to the capacitance can in fact be much higher than the leakage current that is actually due to the insulation resistance of the product itself. We call the leakage current that is due to the actual insulation resistance the real current, and the leakage current that is due to the capacitance is either called quadrature current or you know, reactive current and stuff. It is out of phase by 90 degrees to the applied voltage. So you can potentially separate these two currents and look at one versus the other. But the total current is the vector sum relationship of these two currents, and in many times the capacitive current can kind of swamp out the leakage current that is due to the insulation resistance. So it may be difficult to determine, you know, is the insulation damaged or is the capacitance much higher, on this, type product than maybe something else. So in many cases, the AC test is really considered more of a go-no test, because normally you cannot predict whenever the insulation is going to fail. You can be going through and testing a product, especially if you're applying the potential instantaneously. It's going to be more of a go-no-go type test. Where in doing DC testing, in a lot of cases, you're ramping up the test potential, monitoring the leakage current. You may be doing a step voltage test, where you're charging up the capacitance to a certain level, you're allowing that current to stabilize, and then increasing it again, and going up to the next step, and bringing it up, charging that product up slowly. One thing to keep in mind in doing DC testing, you are typically testing at the peak value rather than the RMS value whenever you're going through and you're doing that test. Okay. Again, DC testing in many cases has been considered to be more of a non-destructive test, typically because you're bringing the voltage up at a much slower rate. You're doing a step voltage test. You are plotting typically the leakage current, maybe on a graph, looking for a linear response for each increase in voltage. If the leakage current becomes nonlinear and it starts to produce a knee, you now can make a decision on whether to continue the test or to stop it. And in many cases, why would you stop the test? It may not be a convenient time to break down the insulation of that product if you're testing something and it is on the verge of failure, but yet the product has been performing. Maybe you don't have the part to replace it, on hand, where you can afford a shutdown at this time, due to a failure. It may be better to go through and schedule a shutdown on the equipment. This is normally done like when you're doing maintenance testing and stuff on certain products and stuff. Okay. Is repeated testing destructive as it relates to product safety testing? Again, I think this question often originated due to type testing, where voltages typically were applied for longer durations. It may be related to doing maintenance testing, where you try to test the product at the same potential that you've done when the product was originally manufactured, and consequently destroyed the insulation of the product. And if you're testing in accordance to that, yes, I would say, a Hipot test is in fact a very destructive test. Especially if you're doing AC testing, you're doing more of a go, no-go type test, and you cannot necessarily predict when an item is going to break down. The test itself, if you're doing a type test, in many cases you may be testing it to the point where it is a destructive test, where you're trying to determine, does this insulation actually break down? People say, well, if I do repeated Hipot testing on something, then it is a destructive test. I've done it so many times that the insulation failed. I don't think that's what I'm trying to stress here in doing repeated Hipot testing. Many cases, the question kind of came up, well, hey, if I'm manufacturing a product and some of the components that I'm using within my product itself were tested by the manufacturer. Okay, so that's one Hipot test that was done on it. Now, when the product comes into my facility and I'm getting ready to use them on my in my product, I may go through and test them. We've done it as part of an incoming inspection where we went through and we've done Hipot tests, especially where we've changed suppliers and we're trying to evaluate the product itself. We went through and we've done, maybe 100% Hipot test on that one particular shipment, to kind of go through and evaluate these things. As products are built, maybe in a sub-assembly stage, the product may be Hipot tested again. Now, once that sub-assembly comes in and is installed within your equipment, now your equipment is tested again as a routine production line test at the end of the line. So, it's conceivable that an item could be tested 4, maybe 5 times, where certain components within the product are tested, repeatedly. Am I damaging the insulation of that product where it could actually be destroying the product itself? And I think that's the question that we're trying to answer in this webinar. Is that type of testing destructive? Do I have to worry about it? And if your product is manufactured in accordance to the specified standards, you're using insulation, creepage, and clearance distances that are recommended, I don't think you're going to run into a problem. We've done some tests here on, various products and stuff, throughout the years, and here's some examples. Back in 2007, when we first put this first webinar together, is repeated Hipot testing destructive? We took a couple different types of products and we did some multiple tests on them. We hooked them up. I had a bench grinder that I purchased to go through and actually do demonstrations with. I originally purchased a bench grinder to, try to take with and use at maybe equipment shows where we set up, a Hipot, and we did maybe a ground bond test, a Hipot test, and a run test on the product that, we could go through and operate where, you'd either, had a motor on it or a light, this kind of stuff. So this bench grinder was a nice little tool because, I could crank up the motor on it and, you could actually see, the product run, the light fixture on the grinder itself, would light up, this kind of stuff. And we would go through and do Hipot and ground bond test on it. It had a ground circuit. So this thing had been tested hundreds and hundreds of times prior to us going through and doing this test on it in 2007, where we wanted to go through and try to prove this out. So I'll show you some of the results and stuff on that. Just last month, or actually, we went through and we did some tests on a couple samples of motors that I got from one of our customers. And I had 2 small motors. These were little 4 RPM synchronous motors. One of them was 115 volt, the other one was a 230 volt input. And we went through and we did 2,880 Hipot tests on these motors, 1 second duration. The tests were basically conducted based upon the agency standards. The customer had recommended that the 115-volt motor had been tested at 1200 volts, and the 230-volt motor was typically tested at 1500. So we went through and we duplicated this. We set it up with a timer, and we went through and we conducted 2,880 Hipot tests, one right after another, doing a 1-second test on on each motor, and recorded leakage currents and stuff on these devices without a failure. Okay. We also did this on a light fixture. Okay. So the light fixture had the most number of tests and stuff that we done on it. This we did a 25 amp ground bond test on the ground circuit. It was done at an 8-volt potential. The test was 1 second. The AC Hipot test followed that. It was done at 1240 volts for 1 second. We did a total of 24,600 tests on this fixture without breaking it down, and basically the resistance of the ground circuit did not vary more than 1 milliohm throughout all the tests, going through testing one, doing a ground bond test and then an AC Hipot test. The leakage current did not vary more than 2 microamps during the 24,600 test. So, doing repeated testing, I think we kind of did an overkill on this from the standpoint of testing it that many times to try to prove our point. Is Hipot testing destructive or not? Here's some examples of what we did on the bench grinder. We did a 25 amp, again, ground bond test, where the ground bond test was a 5-second duration, and a Hipot test was done at 1240 volts for 1 second. This we didn't test as many times because of the duration of the test, but we did a total number of tests was 1,485 tests done on the bench grinder itself. The resistance of the ground circuit on the bench grinder, including the line cord, from the line cord to the chassis, was 53 milliohms on test number 1. On test number 1,485, the resistance was indicating 59 milliohms. We waited about an hour, and we went back through and we repeated the test. And one thing that we noted is the resistance of the ground circuit was, after an hour, was back down to the 53 milliohms. Probably wouldn't have taken that long, but we happened to think about this about an hour later. Well, let's go back and through and retest it again to see if there's any change. And apparently, just going through and doing all the repeated testing, there was enough of the heating, of the ground circuit, pumping 25 amps of current through it for 5 seconds, off for 1 second, going through and doing a Hipot, and then energizing it again, where the resistance did increase slightly, but then once it cooled down, it dropped back down to the original readings. We tried to record both the real and total current on the on the bench grinder itself. The total current on test number 1 was 454 microamps, or 0.454 milliamps. On test number 1,485, the leakage current was indicated 0.494 or 494 microamps. So there was an increase of roughly 40 microamps between the first test and the last test. Again, after we let the product set, for an hour, the leakage current was, again, back down to the 453 microamp level. So, yeah, I don't know if this was just due to, components or, circuitry heating up slightly and going through and doing repetitive testing, this kind of thing. But, very little change in leakage current on these tests. On the two motors that we went through and we did the testing on, the leakage current of the two motors between the first test and the last test really didn't change. The 120 volt motor had 0.033 milliamps of leakage current with 1200 volts applied for 1 second on all 2,880 tests. On the 230 volt motor, the leakage current was a little higher because the test potential also was a little higher. It was done at 1500 volts. It was done for 1 second duration, and the leakage current was 0.043 milliamps on both the first test and the last test. So, do I have to worry about doing repetitive testing on my product, 5 or 6 times? Am I damaging the insulation? I think it can be safely said that I don't think there is a problem where I don't think the test is really destructive in going through and just doing this test a few times, okay? People may come back and say, well, hey, here's some examples. I've tested my product here at the factory. I sent it to my customer, and my customer goes through and tests it, and, he's failing the product, and now he's sending it back to me and stuff because it failed the Hipot test. So, yeah, repeated Hipot testing is destructive. I've gotten those calls. I've went through and I've tried to evaluate some of these potential problems. I'll give you a story of one motor manufacturer that had contacted me with this problem. They were manufacturing this motor, going through and doing a Hipot test on it, and shipping it to their customer. Happened to be, the manufacturer was in one of the southern states and stuff here, and his end customer happened to be out in Colorado. That was at a much higher altitude. And he was going through and taking these motors that had been Hipot tested essentially at sea level, and was trying to perform the same Hipot test at roughly a 5,000 volt or 5,000 foot altitude at the same test potential. He was experiencing some insulation failures where the motors were in fact breaking down. Okay, he in fact sent those motors back to the manufacturer, and the manufacturer was a little upset because of the quantity of motors that were being returned, and in fact the large majority of the motors that they went through and retested also tested good. So there was concern on what was actually going on. And in my evaluation, I had the customer got permission from the manufacturer to have the customers send me a pallet of these motors that had they had basically failed, for me to go through and test and take them apart and try to evaluate what was actually going on. And one of the things that I noticed in going through the pallet of motors that were returned was only about 20% of the motors that were on that pallet where I was able to confirm did in fact fail. The rest of them basically were passing. In going through and evaluating what the customer was doing, basically the end user, I first off wanted to verify what equipment he was using during the test, how he was conducting the test, and I determined a couple issues. I found out that there were in fact actually 5 of these motors used in each of the products that they were being manufactured. And to save time, if they got a Hipot failure during the test, they were pulling out all 5 motors and sending them back to the manufacturer rather than trying to go through and determine which motor actually failed. They found out that it was quicker to do that and let the manufacturer determine which one was bad and which one wasn't. So that was part of the problem. They were rejecting items that, in fact, were, weren't really determined as a failure. One of the things that I did determine was that the motors that did fail were, in fact, failures. They had insulation that was not properly inserted within the product itself. It just so happened at sea level, the test potential that was being applied was not high enough to jump that gap, but yet at 5,000-foot altitude, it takes less voltage to jump the same distance, and in fact there it did create a failure. So the first concern was, in going through and doing this test, is it in fact a destructive test or not? The first look was, yeah, doing repeated Hipot testing was, but in fact, it was more of an issue of the test potential that was actually being applied. If they would have reduced the test potential based upon the altitude, it wouldn't have created a failure. So, that was, one of the issues and stuff involved also. Some standards basically will tell you to reduce the test potential based upon, the altitude also that you're going through and testing at. Okay. Keep in mind, the function of the electrical insulation within the product itself is there to protect against electrical shock hazards. The Hipot test is really performed on our products to try to gain some information about the condition of the insulation. How you use this insulation or this information is really up to you. Would you rather purchase a product that has been tested or one that has not been tested? In my opinion, doing repeated testing based upon agency standards, it is not a destructive test. I think there are a lot of other product safety engineers that would in fact agree with me based upon going through and doing this type of test. Where you run into questions is and problems is where insulation in fact has degraded due to age, and yeah, if you Hipot that insulation, it may fail. So, the product was in fact operating, when I took it out of service, and now when I went through and I did a repeated Hipot test on it, it failed, but wasn't that the purpose of doing the test itself? Was to determine whether that insulation was good or was it bad? So again, keep in mind, why are you doing the test? You're actually testing the insulation to try to make sure that you do not have any of these hazards that could exist, that could create a potential shock or fire hazard. Okay. At this point, we're going to throw it open for a few questions. I mean, we're about at the limit of our time here. Pete, did we have anything that came in that...
We had a few, Dwayne, and most of them I was able to handle. There is one that I think is important and would be good to share with everybody. One of the questions was, how does ramping overall affect the test? Specifically in the type of testing that you were doing, how would a ramp affect it from a damage standpoint? In parentheses, it was the theory of ramp time. But how would the overall ramp time affect this type of test repeatedly?
Sure. In going through and doing a Hipot test, ramping is done for a couple different reasons. It may be done to make sure that you do not have a over voltage upon applying your your test potential, where you could have a surge by applying your test potential immediately, where again, depending upon the Hipot, so you don't have an overshoot that could possibly damage the insulation. Ramping, if you're monitoring the current, in many cases, if you're ramping up the test potential, and all of a sudden you see a nonlinear increase in your leakage current, where the leakage current is starting to raise much higher than what it was, it may help you predict when a failure is going to occur. It will tell you at what test potential the insulation did fail at, if you go through and actually ramp up your test potential. Applying it immediately, if you have a 0 ramp time set up, or maybe 0.1, 0.2 seconds, this type thing, many times it just may indicate, because of the sampling rate of the tester itself, it may not indicate the the test potential. If you're using an analog meter, there still are a bunch of old analog Hipot testers and stuff out there. The response time of an analog meter is anywhere from 2 to 3 seconds. So if you're trying to apply your test potential instantaneously, doing a 1-second test, that meter never settles in on a value before the test is over with. So yeah, ramping can tell you, if a failure does occur, essentially at what potential did it actually fail at. It may help you in predicting, whether an item is going to fail or not. If you're trying to determine some information in regards to a breakdown, is it a true breakdown? Many of the pieces of equipment that are out on the market today have got multiple failure detectors, and they may have a high limit detector, they may have an overload detector, an arc detector, continuity detector, a GFI detector. All of these different detection networks, different ones could be triggered for different reasons. Is it in fact a true failure? Why did it fail? When you define a Hipot failure, it's essentially where the current flowing, through the circuit under test basically rapidly increases in an uncontrollable manner, to the point where it trips off the, current trip setting of the Hipot tester itself. You know, so it's, you know, it's an uncontrolled avalanche of current, again, based upon the, you know, the test potential. So, you know, it's, you know, if you have your leakage current just set something slightly higher, you may, you know, get a false failure in some cases. Again, if you're doing a DC test, it could be due to charging current. If you're doing an AC test, again, you may be utilizing arc detection. Arc detection may not be necessarily considered to be a breakdown. It could be just a single momentary flashover. Some standards say single momentary flashovers are to be ignored if it doesn't result in an avalanche of current that would trip off the current detector. You know, so there's a lot of different reasons and stuff there. Anything else, Pete?
Yeah, Dwayne, we got a couple more actually. Hold on one second here. First, I was actually in the midst of replying, but this is a good one. How does the overall duration of the test, not so much ramp, but the overall dwell, switching gears now from ramp to dwell, how does the duration of the ramp going from, let's say, 60 seconds to 120 seconds impact the results? Is there a notable difference in results typically?
We're talking ramp or we're talking dwell, you know, type thing?
Dwell, total dwell test time from 60 seconds of dwell to 120 seconds of dwell.
Okay. Again, if you're doing a 60-second test or, you know, 120-second test, this kind of thing. When you talk about a type tests are normally conducted at 60 seconds. Routine production line test anywhere from 1 to 5 seconds. But there is also a difference in test potential. The routine production line test is done at a higher potential because it's done at a shorter duration. And, you know, you may see a 20% increase in test potential. 1,000 volts at 60 seconds versus 1,200 volts for a 1-second test. You know, we've done life tests on items where, you know, we've cranked up and, you know, applied voltage continuously. You know, I just read an article in response to, again, one of the webinars that we did, you know, about 2 years ago. It says, some years ago I conducted several tests on a group of power supplies in parallel that we went through and we performed a Hipot test on. It says, I ran the tester for 8 hours a day, 5 days a week. He says, finally, after about 1.5 weeks, I detected some insulation abnormalities. You know, the question was, again, is repeated Hipot testing, you know, destructive to the insulation? Here, they applied the test potential continuously, 8 hours a day, 5 days a week, you know, and after finally a week and a half, you know, the insulation failed. He doesn't say in his little note here what test potential he applied. You know, how does this compare to what would normally be done as a 1-minute test? You know, where longer durations, corona does, you know, can degrade the insulation. It can cause a failure where it will finally eat through, you know, the insulation and create a failure itself. So, yeah, depending upon how long you're doing the test, that can, in fact, be more destructive than, you know, just doing a short, you know, Hipot test and stuff. Anything else, Pete?
Oh, we're looking good, Double D. All set.
Okay, very good. Again, this was our first webinar that we've done this year. We've got another one, I think, scheduled next week that you know, is just kind of a brief overview of electrical safety testing, and it kind of covers the you know, Hipot testing, ground continuity, ground bond, you know, some of the, you know, touch current test. Again, it's kind of a quick, brief overview. We're trying to cover, you know, 4 or 5 different types of tests in a 1-hour period. So, you know, it's not spending a great deal of detail, but it gives you some ideas as far as the, you know, why are tests done, and, you know, a little bit how they're done, this kind of stuff. So that, I believe, is next Wednesday, Jim, if I'm not mistaken, at 10 o'clock also.
Yep, that should be it, Dwayne.
Okay, very good. I invite everyone to join us, you know, for that webinar. You know, check our website to see what is scheduled throughout the year. I think we've got about 12 webinars scheduled through the remainder of the year here. And, you know, we, if you have questions concerning this material or any other questions, please, you know, shoot us an email and give us a call. You can send an email to info@associatedresearch.com, and it will be directed to either myself or Nick or Pete, somebody that will try to get back to you as quickly as possible, and you know, try to get your questions answered and stuff there. If you'd like a copy of this presentation, you can shoot an email to Jim Kennedy. This has been recorded, so it is going to be on our website probably, what, tomorrow, Jim, I would imagine? Next, you know, within the next couple of days. You know, you can use these webinars for doing, you know, training and stuff of, you know, other individuals and stuff in your company. You know, and again, if you'd like a copy of this presentation, shoot Jim an email, and he will send you a copy of the, you know, the webinar itself, you know, the PowerPoint presentation. So, with that, I thank you. Invite you back next week, and have a great day.